over here. So the I vector would be 1, 0, 0, which is like this. This would be the I vector. And notice that we have kind of triangular parentheses over here. This indicates that it's a vector. So if you were just to use, for example, here, 1, 0, 0, this would indicate a point on the region and not actually a vector. So this and this, x, y, z, would indicate a vector. Okay, so red is the I vector, and then the j vector would be 0, 1, 0, which is in this direction. And then here, let's make this in a different color. Z vector would be up here, 0, 0, 1. Okay. So here it says, find the component form of the vector u with the initial point -2, 3, 1, and terminal point 0, -4, and 4. Then find the unit vector in the direction of u. Okay, so what you want to do first is u vector over here, okay? To make this easier, let's call this point P and this point Q. So P to Q would be -2, here, -2, -0, 3 plus 4. So right now we're basically just subtracting these to get a vector. And then 1 minus 4. So we're going to get -2. Wait, hold up. Okay, yeah. -2, 7, and 1 minus 4, which is going to be -3. Okay, and if you were to do this in the opposite direction, so if you were to make this P and this Q, you'd have the exact same answer, but the signs for each of these three values would just be switched. So it would be +2, -7, and +3. So we have now U equals -2, 7, -3. So we want to find the magnitude of U. This answers one of our questions actually, which was find component form of U. Keep in mind, component form means these triangle brackets. Okay, so we want to find the magnitude of U, vector U. So how you do this is like -2 squared plus 7 squared plus -3 squared. And make sure to keep all your numbers inside brackets so you don't get mixed up when you're squaring them. This is just going to be the square root of -2 squared would be 4 plus 49 plus 9, which is going to make 13 plus 49, which I believe is 62. So then to find the unit vector over here, the equation for a unit vector, which I don't think was mentioned in this video, is U over the magnitude of vector U. Okay? So we have U over here, which was our first answer, and then here we have the magnitude of U. So what you want to do is basically here, let me just, would be -2, 7, -3 all over square root of 62. And that is our final answer. This was also first part of our question. Okay. So next example. Determine whether the points P and Q and R are collinear. Okay, so what you want to do here is, first of all, find P to Q, which was kind of shown how it's done in the example above. P to Q would be 1 minus, keep in mind here, 1 minus 2 okay, comma, minus 2 minus 1, comma, 3 minus 0, 3 minus 0, equals minus 1 minus 3, 3. Oh, I made a mistake over here. Okay, so up here, when you're finding P to Q, you're gonna, it's terminal, tail minus initial, okay? So I did this wrong. It's gonna be here, like this. 0 minus 2, minus 4, minus 3, and then 4 minus 1. So it's just going to turn out to be plus 2, minus 7, and 3. Yep. And then you're going to end up with the same answer, but I just wanted to clarify that it would be Q minus P and not P minus Q. So same with over here. So it's going to be 2 minus 1, comma, 1 plus 2. Keep in mind negative over there, so you just add it on. And then 0 minus 3. So you're going to end up with 1, 3, minus 3. And then we want to find P to R. So P to R. Okay, so don't make the same mistake I did and do it the other way around. So it's going to be 4 minus 1, 4 minus 1, comma, 7 plus 2 plus because of this again. Make sure you don't forget that. And then minus 6, minus 3. So you're going to end up with 3, 9, and then negative 9. Okay, so using this piece of information over here, okay, we're gonna factor this out to determine whether these points are collinear or not. So P to R is equal to 3, 1, 3, minus 3. So I just factored this out. So I'm going to move the PQ answer down here just so you can see it. So for PQ, we also got 1, 3, and negative 3. And then same thing for PR, but it's just multiplied by a constant, which makes it bigger. So you can write here that PR equals 3 PQ. Hence, PQR are collinear. Okay, so now you want to write this in component form, which is pretty simple. So we have V equals, so I mentioned earlier that I represents X, J represents Y, and K represents Z. We don't have a J over here, so it's just going to be a 0. So what you want to do, 4i, which is 4 in the X direction. So the first component would be a 4, which is X, okay? Comma, there's no Y's here, so 0. And then negative 5k, which is negative 5 in the k direction, would be minus 5. That's pretty much it for this one. Okay.